We're going to start off by taking a look at the inside portion of the Earth. And the inner core is the innermost piece of the Earth. The best way to draw this picture is first to draw this sort of like triangle thing here. And then draw this line here. And then draw this line here parallel to it. And so on. The inner part of the Earth is called the inner core. The inner core is solid. It's made of solid iron and nickel. And the inner core of the Earth is something that we now know to be moving and spinning. It's a spinning ball of solid iron that generates its own magnetic field, electromagnetic field, by its motion. So in its motion, because it has magnetic particles in it, and because it's moving, it's generating an electromagnetic field. And we know that as the Earth's magnetic field that extends out into outer space, protecting us from the ions of the sun, reaching us completely. In some spots where those ions get through the Earth, through the magnetic field in the north and south poles, we have the aurora borealis, the aurora australis, the auroras. And those are the ions from the sun hitting the Earth's atmosphere. The next piece, the next layer of our Earth is called the outer core. The outer core is liquid. It's not liquid like water. It's liquid kind of like molten lava, but even thicker. Okay? So we have the inner core, the outer core. The inner core is solid, the outer core is liquid. The next thing that we have is called the mantle. The mantle. The upper orange area of the mantle, and the mantle, by the way, is also liquidy. And there are convection currents moving that liquid magma inside the Earth. Okay? Above and including part of the mantle is the lithosphere. The lithosphere is the outer crusty part of the Earth. And it's made up of the crust, which is the outer piece, the outermost piece, and the uppermost part of the solid mantle. This green part right here is the mantle that's solidified. The asthenosphere is liquidy. And of course the crust, the upper part of the lithosphere, is the most solid. It's the part that's exposed up on the very surface of the Earth. Okay? Does that make sense? So this is really a view of the Earth that doesn't really show that the inside of the Earth is moving. Okay? The inside of the Earth is moving. Now that's really important. Really, really important. And Sir Alfred Wegener the guy that I told you about earlier, that came up with this idea that the Earth is a molten ball of liquid rock on which there's solid plates, continental plates and ocean plates moving. He's the one that came up with it and thought of it. This picture doesn't show that. I'll show you that picture in a bit. Okay? All right. Okay, ready to move on? If you don't get a chance to copy it right now, if you haven't been writing, if you've just been listening, that's okay, because I'm going to post this on our website. Okay? All right. So one of the things that we're going to want to know from Chapter 4 in Section 1 is that there's different types of waves. Different types of waves. There's two types that we're going to be concerned about. Two types. Transverse is one of them. Write this down. Transverse is one of them. Transverse waves are side-to-side waves. Like if you took a slinky and moved the slinky perpendicular to the length of the slinky, that would be a transverse wave. It's a side-to-side motion perpendicular to the direction of the wave. Write this down. Another type of wave is called a longitudinal wave. A longitudinal wave. A longitudinal wave can be thought of as if you were to take the end of the slinky and push it forward in the direction that the slinky is going instead of side to side, you could see the waves of compression that go through the slinky. It's a back and forth direction parallel to the direction of the wave. Write this down. Write this down. And if it helps to draw that picture down there of the slinky, go ahead and do that. Okay, does that make sense? Now, these two different types of waves are going to be really important for our understanding of how earthquakes move. And by understanding earthquakes, we can see inside the earth. Earthquakes are our way of seeing the earth on the inside. Okay? Earthquakes are our way of seeing Earth on the inside. Okay? Okay, let's watch a video of this.
A wave is a periodic disturbance in space and time. Waves, such as a sine wave, can be characterized by its frequency, which is an inverse time period, and ascending. They generally propagate in two forms. Transverse waves oscillate perpendicular to the direction of propagation, while longitudinal waves oscillate parallel to this direction.